All right, welcome everyone to the next week of class. This is really, really funny to me. So last week we talked about section 1.3, the derivative and limits. And this week, as you can see, the section number is 1.4, limits and the derivative. So all they did was just switch the order of the words, but it's different stuff, okay? I'm not sure what the authors of this book were thinking, but it's kind of silly to me. All right, so we're going to talk about limits and the derivative today. And new stuff though, don't be fooled by the title. So there are some really precise definitions of the limit here, but again, in this class, we really are focusing on applications. So we're just gonna give a very informal definition of what we're gonna talk about when we talk about limits, okay? So this is what we write. The limit as x approaches a of g of x equals L is pronounced the limit, well, just like I did pronounce it, the limit as x approaches a of g of x. And we say that this is L if g of x, the function value, the y value, gets really close, and this is where it's not really precise, it's really close to this limit value L, as x gets really close to a. All right, and there are some really fancy definitions for this, but this is essentially what we're going to be using in this class, okay? So the limit as x approaches a of this function equals L means that the y values get really close to L as the x values get really close to a, like this. So let's kind of see this in action, okay? We're going to show this off with example 1. All right, use the table below to find the limit as x approaches 2 of the function 3x minus 5. So I'm going to give you a table here, and you're going to use the table to figure out what this limit equals. Here's the table. So we're going to look at two things. We're going to look at what happens from the right, and we're going to look at what happens from the left. So this table is going to be given to you. There's going to be a bunch of different values of x's that are probably going to be right behind my head, a bunch of different values of the function, right? So remember right here, right? This obviously is x, and this right here is g of x. So remember what we said the definition of the limit was, our informal definition. We said, right, as g of x gets close to the limit, as x gets really close to a. So what we're going to expect is that these x values are going to get really close to a number, and hopefully these g of x values get really close to a number as well. When x is 2.1, the function value g of x is 1.3. And remember, we want x to get really, really close to 2. So this table that will be given to you, when x is 2.01, we get 1.03. As x is 2.001, we get 1.003 as the function value, and so on. There's this pattern here. So on the right side, right, as x is getting really close to 2.1, and then it's getting closer, 2.01. X is getting even closer to 2.001. X is getting even closer to 2.0001. Hopefully, this function value, this g of x, hopefully this is also approaching something. And if you look at these numbers and how they change, you should see what it's approaching, and you should have a guess of what the answer is going to be, what this limit is going to be. As x approaches 2, g of x, this function, should be approaching a number as well. But that's not it. We're not done yet. We filled in the right part of the table. Now let's fill in the left part of the table. Also, I know this is bothering some people. It bothers me too. I just using this problem from the book. I'll admit, I realize that the right is on the left and the left is on the right, but that's how it was given to me. And I didn't realize how much it was going to bother me until now. So over here, let's look at what's happening as x gets really close from the left. So when x is smaller than 2. From the right, these are all numbers that are bigger than 2. From the left, these are all going to be numbers that are smaller than 2. 1.9, the function value is 0.7. 1.99, the function value is 0.97. 1.999, 0.997. You get the picture, right? And as I fill in this last row, we should start to see what is happening with this function. As these x values are getting bigger and bigger, closer and closer to 2, the function value, the g of x, is also getting closer to a number. And hopefully the number that these are getting close to and the number that these are getting close to are the same. And indeed they are, right? It's getting close to 1. So what we would say for our final answer, that I really wish I could fit on this page, but I'm just going to use a little eraser magic to make this work. What we're going to say is that the limit as x approaches 2 of this function is equal to 1. Because from the right, it approaches 1. From the left, it approaches 1. So the limit is 1. And that's the basics of what we're doing here today. All right. But now we're going to look at some things graphically. Okay. So let's move on to example 2, last part of the video for this one. Find the limit as x approaches 2 of these functions. So we're going to look at things graphically and let's see how it compares to doing it with that table. So, whoop, that's that's the wrong hotkey. All right, so let's look at this graph. Here's our first function. This is part A. All right. So for part A, as x gets really, really close to 2, what does y become? What does the function value become? So, look, when x is 0, the function value is down here. When x is 1, function value is down here. But as x gets really, really close to 2, we approach this point, right? As x gets really, really close to 2, look at the y coordinates. Look at the y coordinates. Negative 0.5, negative 0.3, negative 0.2. As x gets really, really close to 2, the y value gets really, really close to 0. Okay? So the limit as x approaches 2 of this function is 0. As x gets close to 2, the function value gets close to 0. All right, so for part A, it's going to be the limit as x goes to 2 of f of x is equal to the 0. Because y approaches 0. And you might say, Jason, this doesn't make any sense. It's just the function value, right? As x gets close to 2, yeah, we approach this point on the graph. Well, that has to do with something in the next section, which we'll talk about as continuity. And yeah, if a function's continuous, the limit is just equal to the function value. We'll talk about that more in the next section. All right. Let's look at another one. So this is going to be an example of a graph that is not continuous. Okay. And again, we haven't introduced the idea of continuity yet. That's going to happen next time in our next section. This is a very similar graph now. This is part B. And now the function value, f of 2 is equal to positive 2. It's not continuous, right? As we get close, it really approaches the same spot, but the actual function value is up here. This is a piecewise function, okay? But the limit is the same thing, okay? This function has the same limit as the other function because it doesn't actually matter what's happening at this point up here. All that matters is as x gets really close to 2, y is getting really close to 0. In this one, the limit is again 0 for this orange graph. Okay. So in part B, the limit x approaches 2 is equal to 0. Going to part C. Part C is another piecewise function. Okay, this is a piecewise function. It has two different pieces, and each piece is part of a parabola. All right. Now in this function, as x gets really close to 2 from the left, what is our y value getting really close to? Y value is getting really close to 0. But on the right, as x gets really, really close to 2, the y value is getting really, really close to positive 2. So from the left, it's approaching 0. From the right, the y value is approaching 2. Since these don't agree, there is no limit. These two things have to approach the same thing. From the left, it's approaching 0. From the right, it's approaching 2. So there is no limit here. The limit does not exist. All right. And a lot of times we'll abbreviate this DNE, or does not exist. All right, last one for this video is going to be part D. And part D is going to look a little something like this. This is a reciprocal function. And as x gets really close to 2, again, we have a similar situation, right? From the right, look at these x values. These x values are getting really close to 2, and the y values are getting bigger and bigger and bigger. And in fact, they'll get bigger and bigger forever. So from the right, as x approaches 2, the y values go off to infinity. From the left, as x approaches 2, the y values go off to negative infinity. All right, so again, this is another example where it's going off to different directions on either side. And again, infinity also is some weird cases. We're going to say for part D as well that the limit does not exist. All right, so these are kind of the basics of what it means for a limit, what it looks like graphically, and what it looks like analytically with a table or with some numbers, okay? We're gonna do some more problems with some properties in the next video and some shortcuts. All right, and then we'll get into some really nasty stuff later on in this section. Good luck.